Many of you probably know of someone who had a stroke. This is a debilitating, life-changing event. Part of the brain dies and the mind-body connection is lost. To better understand this problem, I interviewed stroke survivors and therapists. They emphasized lack of hand control, including difficulties grasping and opening and instability, problems which leave the victim dependent on others for even the most basic tasks. Current medical devices are inadequate. They come in limited sizes and either prevent motion or constrain the hand to move unnaturally. But we have a solution for that. I'm developing a powered hand orthosis to help stroke survivors regain their manual dexterity and independence. A smart CAD package I made generates custom-sized part files that can be rapidly 3D printed, reducing the need for a skilled orthosis technician. Flexible joints will enable multi-axial mobility, and active intelligent control will provide the needed assistance for users to perform activities of daily living independently. Of about 800,000 stroke victims in the US every year, most survive. After rehab, 40% of these have mild to severe impairment, the target population. Most of these are insured and would be able to receive this device from their therapist for at-home use. My name is Alyssa Ledoux, and I'm a PhD student in mechanical engineering. I'm personally invested in this project after seeing how a stroke affected my grandmother a few years ago. And after doing similar work designing robot claws for industrial automation, I know what I'm doing. It's actually because I got tired of redesigning claws for every customer that I created my own automated solution, and then realized I could apply those same principles to humans. A grant would primarily fund prototyping supplies to continue making this solution a physical reality. Thank you for listening. Are there any questions? All right, so, and we'll go back through. I have identified the problem, but then one thing that I realized, or that I had to do for this class, was interview potential customers or end users, people related to the project, to make sure, because I want to make sure that whatever problem I'm addressing is a real problem, or maybe the problem needs to change a little bit or something like that. So I realized, or I knew at first, that people who have a stroke can have trouble grasping, but what I didn't know is a lot of it depends on where in the brain the stroke was, what part of the body it affects. And many people, they have trouble not just closing their hand, but they also have trouble opening it. So many of them have spasticity. So their hand, like the guy in the picture, is just like all clenched up, and their entire arm sometimes it's just like all clenched up like this because their muscles are like continuously in spasm. So they need help opening their hand in addition to closing. And the other thing is they can't always control how many fingers or which fingers they use. So if they want to pick up a small thing or a big thing, or like grab a can, so like a cylinder shape, or a ball, like they can't necessarily control which fingers are doing that. So then I realized I'll needed to adjust actuation and control method from what I had originally intended. Because for some people, like if I could put sensors in it, they'll know which direction it's trying to move its hand. That would be real intuitive. But if they can't control their hand, if they don't even know which fingers to use, because like their brain has forgotten about that part of their body exists, then they may need a different option, like a button that they could push with their other hand. So depending on what ability someone's at, then they will need probably different types of control and different levels of assistance too, because as they're stronger, then they won't need as much assistance. And like, hopefully after they're using this, then eventually they'll get totally off of it. So then problems with current devices. So the other thing you want to do is see what's out there that's similar to your product, or what solution are people using right now that might not be adequate. So that will kind of show you who your competitors are and what you can do to beat them out of the market. How is your solution, how can your solution take those good qualities that those things have and improve upon them, or do something totally different that's like maybe cheaper or easier or solves the problem better for these people. So as you are talking to potential customers or whoever else, anyone who's involved with this, then you'll want to ask them, like, what are they currently doing to solve the problem? Is that a good solution? How bad is the problem? Is it like magnitude, frequency, you know? Is it something that happens every day? Is it something that only happens sometimes, but when it does, it's a really big deal? So those kinds of things. So once you have a good handle on the problem, then you want to offer the solution. So every project that y'all are building, it has kind of a problem in the project proposal statement, you know, and then it's got, for the solution, it's got the different design constraints that you've got to meet. But how you meet those is kind of up to you, the actual design of the system. Or you might think of additional things to add. So here, you can see, like, I laid out lots of things that my device has that the current solutions don't have. So like custom sizing, if the previous or like current devices, they either come like, you know, all made for 50th percentile male or like small, medium, large or something, but half of, like, most people who have had a stroke are not 50th percentile male. I mean, some of them are female, or some of them have bigger or smaller hands. And then rapid manufacturing. So now, if they do want a custom made device, somebody's got to take molds of their hand or measurements of like all the parts of their hand, and then a technician has to like spend time actually forming that. And then it's an iterative process. So like they'll form it, they'll go back to you, you try it on. If it doesn't work, they like mark, you know, where they need to change stuff, go back, do it again. But with the custom sizing that I have developed, so I basically took anatomical data for all of the different, but like parts of the hand. So like palm, finger, length, width, where each of the joints are, figured out mathematical relationships between hand length and width and all of those other things. And then I programmed all of the equations into the CAD so I can type in hand length, hand width, and it'll regenerate a custom sized part like pretty much instantly that'll fit those people. I think I have, this is kind of what the interface looks like. So like here, hand width is HB, hand length is that. So I can type those in and then this will instantly change size. So now going back. Okay, so then the other one, rapid manufacturing. Also, a 3D printer doesn't have to be babysat. So you don't need to pay somebody who has a special degree in orthosis manufacturing to be able to do that. You know, somebody can just put in the file and click go and be running lots of 3D printers at the same time instead of only being able to work on one orthosis for one patient that day. So then the flexible motion, that was with the joints, and then the active intelligent control, because obviously you want it to be easy for someone to use. So that kind of thing is the value proposition. So like, who is going to use it? What are they going to use it for? And what are measurable things that you can do to prove that yours is like meets certain requirements? So for all of y'all's requirements, most of the requirements you'll have are quantifiable. So when you're doing your testing, you can quantify your results and see, do they meet the project objectives? So just trying to get statistics or numbers wherever you can in order to highlight what's good about yours, how you have been successful. Market sizing, we'll actually talk more about this in a couple weeks. But basically you want to figure out who all might possibly use your device, and then finally the end is who's actually going to pay for it. So then finally, you want to give them assurance that you're invested in this project, you know what you're doing, and you've started and you have a game plan. So all of y'all have done substantial work on your projects. You also picked them, so you have personal motivations for them. And a lot of you have related experience either with like directly the subject that your project deals with, or doing similar things, you know, like different types of programming, or like using an Arduino or anything like that, you know, that's kind of related to it. So then at the end here, because I was specifically pitching to investors, I was asking them for money. So I knew that they had a grant that they could give, and I wanted to be the person who got it. And if you're just trying to explain to someone what you're working on, but not trying to actually get a donation from them, then you can leave out the money part. But it's good to talk to other people about what you're doing, because some of those people may have experience in your field or other ideas that you could implement on your project, or they might know of someone else who knows those, or know of someone else who has free donation items or something like that.